Hello, it's Mr. O'Mara here, and I'm just doing a quick tutorial to get you ready for your test. We've done all of this stuff before, but this is just a reminder. So this is solving for x, but it could just as easily be for n or a or b. It doesn't have to be x, it's just x is the most common. So let's have a look at what is called a one-step equation, and the reason, or solving a one-step, and the one step is because there's only one step that you do. So for instance, we have 10 plus x equals 2. So what I need to do is just do one step to get rid of that 10 there, because I want to get the x on its own. So what I'm going to do is the one step is 10 minus 10 plus x equals 2 minus 10. So I'm taking minus 10. I'm doing minus 10 on both sides. That gives me the x on its own. 2 minus 10 is minus 8, and there is in fact my one step. So I've taken 10 from both sides and I have the solution. So to look at another one like this, I've got 2x equals 20. So what I'm going to do is I'm going to divide both sides by 2. That's my one step, which means that x equals 10. So for some things you're just looking and saying, what can I do to both sides to get x on its own? But sometimes you'll have to do more than that one step, which brings us to a two-step equation. For instance here, I need to actually do something which is two things to get x on its own. So the first thing that I'm going to do in this particular one is I have got an x's on both sides. So to get them only on one side, I'm going to take away 4x because I've got 4x here and I've got 5x here. So it's going to leave me with x there, and that equals 1. And I've actually just realised that is actually a one-step equation. So that wasn't a very good example. And what's more, I actually think, no, yeah, x is 1. So let's see if this one's a little bit harder. And let's see if this one genuinely is a two-step. I think it probably is. So I've got x divided by 3 minus 10 equals 12. So the first step I'm going to do is I'm going to add 10 to both sides. So now when I add 10 to this side, it gets rid of that. And when I add 10 to this side, it goes there. So I've got x divided by 3. So now I'm going to times both sides by 3. So when I times x divided by 3, I get x. And when I times 22 by 3, I get 66. So that is a genuine two-step equation. That one on the other screen was actually a one-step equation. This is a 2. And this, we actually accidentally had one of these a minute ago, is an unknown on both sides. So I've got 2x plus 6 equals 8x. So what I'm going to do, because I've got x's on both sides, is I'm going to take away 2x. So 2x minus 2x plus 6 equals 8x minus 2x. So as you can see, I've got 6x left on this side, and my 2x and minus 2x cancel each other out. 6 equals 6x. So x equals 1, and I'm going to turn it around so that I have x first. These are simple ones, that's why they're always ending up as 1, but they could be any number. And finally, so here I have it again. 3x minus 25 equals minus 2x. So what I want to do is I want to get rid of that minus 2x. So 3x plus 2x equals minus 25, negative 2x, but I'm adding 2x here. So those two cancel out. I've got 5x on this side, and I've got minus 25 on this side. So what I'm going to do on both sides is I'm going to divide them both by 5. So it's 5x divided by 5 to get it back to x, minus 25 divided by 5. So x equals minus 5. So as you can see, I was able to, by taking away, or actually adding in this case to get rid of that, I was able to get the x's all gone off one side and all over to one side of the equation where I can solve them using a one or two-step process. So I hope this has been useful to you, and good luck with your test.